I'm now going to present the UDN on the Diagnosis Network project, Patient-Centric Information Commons, where all UDN patients involved within this program went through a deep phenotyping with all the different HPO clinical terms that has been collected with the knowledge extracted from all the natural language processing from the referral letters, and also all genome and all exome full annotated VCF. Everything has been integrated into one central patient-centric information commons, enabling to do patient-by-patient analysis or population-level analysis on those very rare diseases. Taking the example of one use case, this UDN patient, 17-year-old male with collateral features suggesting of hereditary connective tissues with multiple renal malformation. It has been confirmed within this project that the gene FBN1 was affected with a mutation, and then the Marfan syndrome was confirmed for this patient. Now I'm going to show you how, using the patient-centric information common, we can reproduce this result, where you can look at, the first example will be looking at the 3 years data coming from this case with the affected proband and 2 controls for this patient. And then I'm going to look at the functional impact using as a gene model RefSeq, the non-synonymous, with any polyphen2 or a SIFT mutation. And then now I'm going to filter all the variants from this trio, where I have 78 candidate transcripts from 55 candidate genes, where I can filter by adding a phenotype of connective, non-connective issues, and using the Find Zebra annotation database that makes the link with potential phenotypes with variants, and then exploring directly from the VCF. That's where you can find the FB1 gene was affected in the proband and not in the unaffected parent. So this is an example of using the VCF data, and now looking into at the population level, where I can explore all the data coming from all the demographics across all this UDN database, where there's more than 923 patients that has been integrated. I can explore the primary symptoms reported by the patient caregiver. Well, there's 43 patients, for example, where it was a cardiovascular or vascular condition. Or I can look at the sequence that have been submitted, the type of sequencing that has been submitted from all the different UDN clinical sites. So each yellow folder represents one layer of the pancake with all this patient-centric information common. Now looking at, for example, the clinical symptoms and physical finding, where I can explore using phenotype that has been collected with using phenotype, using the HPO classification, going down to abnormality of the connective tissue. 4 patients, PC, patient count, 412 patients. So our previous patient is definitely included in this, but then I'm interested in looking at all patients that have an issue of the connective tissue, where I can just do a drag and drop and then generate summary statistics, where I'll have the histogram of age, sex, and race across all those patients. And then I can explore on also in the second subset all the patients that do not have an anomaly of the connective tissue, creating a comparison between both groups, between on the left, abnormality of the connective tissue, 412 patients, and on the right, patients that do not have an abnormality of the connective tissue. And you can see that the mean age is 19 years old with the abnormality of the connective tissue versus 22 years old from the not having an abnormality of the connective tissue. And then I can compare any of the phenotype that has been integrated within the system to be able to explore and across all those different elements based on the different diagnoses, the exome sequencing data, the family history, and also integrating, for example, the different metabolites. So if I'm, for example, generating an hypothesis, I want to look at the creatinine level across between those two groups of patients. I can just do a drag and drop. I can see that the creatinine level in 64 patients with the abnormality of the connective tissue versus the one that doesn't have an abnormality of the connective tissue, where both of them are not significantly different at the 95% confidence interval. So this platform enables to integrate and to be able to explore any data coming from the clinical data, the genomic data, the metabolic data, in order to generate hypotheses.